Welcome back to Mechanics and Control of Robotic Manipulator. So last lecture what we have seen, basically like we gave an introduction to the course. So very basically we very informally we started what is robot, and we started talking about what is manipulator and types of manipulator. In the last lecture itself I said that this particular second lecture going to talk about robot mechanics, basically the introduction to robot mechanics. Then we will be talking about degree of freedom, and finally we end with kinematics, right? So in that sense what we are actually like focusing here is basically the mechanics. So the mechanics is actually like come with several things, because it is actually like a motion system. So the motion system need to be defined, right? So in the sense the motion need to be defined, so we should know like what is description. So what is description? Then we should know, like for describing you should have a reference. So then for referring it, so you should have the minimum number of variable. So minimum number, these all would be coming, right? So in the sense we would be talking about this particular lecture, we would be seeing very specific robot mechanics. We'll see like what is configuration, what is description, and what are the description we can see. Finally we will actually like start a very simple keyword called DOF, in the sense degree of freedom. Then we end with robot kinematics. So this is what we planned for this lecture. Let us see what we can actually like cover in this. So we'll start the manipulator. You know manipulator can be defined, so an effector that has an effect on the environment, okay, which has actually like effect on the environment, causes motion of the objects around, you call it is manipulation, the device which you call manipulator. If you talk about manipulator, obviously it is, you can see it is a multi body system, so or multiple body system. So since it is multiple body system, so we have studied whatever in the kinematics and dynamics of machinery may not be straight away you can apply. So then we should know like what the method we can do it. So but this is also like very similar what you have studied as a linkages or mechanism or kinematic chain. This is also like one kind of kinematic chain. So what it would be having set of bodies arranged or connected as a chain with the help of joints, which we call constraint. For example, now you take one body, okay, this body is connected with another body, in the sense you have constrained, in the sense you take this body and actually like grounded with this pin. So now what happened, the ground and this pin is actually like grounded. Now this body is actually like rotate with respect to this pin. So now what you did, you have actually like constrained these two body with this particular, you can say, connection. So that's why the joints we simply call constraints, and generally the bodies in manipulator we call link, okay. So this is the basic idea. So now you know manipulator is very simple. It is very similar to what you have studied as a kinematic chain in your, you can say, kinematics and dynamics of machines course, but here it is actually like multiple body, there also multiple body, and here multiple degrees of freedom will come, and we will see how that can be further enhanced, okay. That is what we are going to see. If we are actually like talking about that, there are two keywords which are actually like thrown. So what, so you need to actually like provide some kind of information about that, or you have to describe something about this motion system. So then we need to have some kind of attributes which is going to describe. So in the sense what we are actually like use a specific attribute of various objects with which a manipulator system deals. So this is what you call description. For example, if you talk about motion system, what are the description you have to give? The motion description you need to give. The motion description can be further given as, so positional change, or you can say the orientation or rotation change, right. So these are the two changes you have to mention. So in the sense, so you have to describe the position, orientation, further you have to describe the positional change, orientational change with respect to time, like that you can keep going. So in that sense you can see the description is one of the key. For describing you should have some reference. For example, so you are actually like calling me as actually like short height and dark skin. So these need some reference. The same dark skin cannot be applied if we go probably some of the, you can say, continental countries like African countries and all. Why? Because the dark is actually like relative with respect to which entity you are. The similar way the short in height may not be applicable if we go to Mongolian countries, right. So, they may be actually like shorter than me, then I cannot be called as a short. So, then you should have a reference. So, you have to actually like make one of the reference. In this particular course, we are going to talk about one of the major reference system which we are going to consider here is the Cartesian coordinate system, which means the three mutually perpendicular axes consist. So, that coordinate system we are going to use. Okay. So, further what we have to see, so the set of bodies how it is arranged that make one configuration, right. So, in the sense for example, I take so two bodies I taken and took the ground. So, now I am arranging it like this. So, this is one body and this is another body. So, this body is arranged in such a way that it is actually like a circular pin is connected, and now if you look at this is 1, 2, 3 bodies are there, these are arranged. It is giving what? It is giving some kind of arrangement. This kind of arrangement what we are going to call as a configuration. So, what that mean? It will give a complete specification of location of every point of that system. So, here it is actually like a manipulator. So, in the sense what? If you call configuration, that would be complete specification of the location of every point on the manipulator. So, for example, if I take this is one of the configuration which is I call two serial rotary link as the configuration, then this can give all possible you can say points of the manipulator, in the sense location of every point on the manipulator. So, that is what we call configuration. So, now we will actually like see further and further. So, what we are seeing further and further, we would be throwing one of the keyword called workspace or work envelope. What that mean? You know, like we are talking about a robot, that to manipulator. You assume that this is actually like one of the you can say serial chain manipulator, and this is the end and this is the base. So, this is base and end. So, this end effector how much actually like it can cover. So, by rotating these three links, how much area it can cover. Okay. So, that is what we call actually like workspace. If it is in a 3D case, it would be giving a work envelope or work volume. So, this is what we simply call workspace. What that mean? It is the total volume swept out by the end effector as the manipulator execute all possible motion. For example, I connect one of the motor here that rotate 0 to 360. This is also going to rotate 0 to 360. This is also going to rotate 0 to 360. So, then this length L1, L2, L3 all are known. So, what would be the all possible configurations of this system? So, that is what you call work envelope or workspace. Okay. So, now you got this. So, then you can see the workspace can be further classified. So, one is all reachable point you call reachable workspace, but certain point you can see like the orientation of the end effector can be arbitrarily fixed anything, in the sense this is the end effector orientation, this can be orient 0 to 360, then that would give a small confined workspace. Okay. But what additionally it will give, any given orientation it can fulfill. So, then what you can see, that is actually like you call dexterity. So, in the sense that workspace you call dexterous workspace. So, that is what we are going to call. So, one is reachable workspace, in the sense entire set of points reachable. In other way around you can say entire set of configurations possible you can actually like see, and that is what you call reachable workspace. If you look at the end effector point and trace it on the configuration, that is what you call reachable workspace. So, now in that subset the dexterous workspace, that means those points that the manipulator can reach with any or an arbitrary orientation of the end effector, in the sense it can go 0 to 360 degree of the orientation of the end effector. So, that is what you call the dexterous workspace. So, now I hope you are clear what is envelope, what is description, what is configuration. We will go one additional phenomena which is important for the course. What is that? Degree of freedom. For understanding this, I am just giving a small example, just a small example. Okay. So, somehow you are actually like attended my lecture. Okay. So, one of your faculty who come across, he visited IIT Indore when I was there. Okay. So, he has actually like come across and you are actually like trying to explain about me, unknowingly you forget my name. So, then what you are actually like going to give? So, you are going to describe about me so that your faculty who has actually come across IIT Indore can recognize me. So, now what you may say that, So he is actually like one of the robotics expert. So in that case, IIT Indore probably 3 or 4 would be there. So you can say that he graduated from IIT Madras. So in that also, like there are 2 people who graduated in IIT Madras and working in the same department. So then you say even mechanical, I already said it is same department. Further you are saying that this faculty traveled Germany. In that case also, like 2 of the faculty traveled and stayed in actually like IIT Madras for their PhD. Then finally you say that right now he is actually like in IIT Palakkad. Okay. So then he is easily recognized, oh you mean to say Shantakumar, I know him. So if you actually like miss any one connection, for example you straight away you say that he has actually like moved IIT Indore to IIT Palakkad, then it is not sufficient, because there are 2 or 3 faculty who moved from IIT Indore to IIT Palakkad. Similarly, simply you can say he is a robotic expert, that is also not sufficient. In the sense, in order to understand or in order to recognize me, you have thrown a minimum number of variable to recognize me, right. So or minimum description. So that is what we are actually like going to call as a general degree of freedom. What that means, when you want to describe the system, what are the minimum number of variable to, you can say variable required to describe the system in a unique sense. So that is what you call minimum number, what you call degree of freedom. This minimum number of variable even you can call as independent variable, both are same. So in that sense, I will just give a simple example. It is actually like a planar manipulator. Okay. So this point I need to define. Okay. So only this point. So then what are the ways I can do? I can draw the x y axis. I can draw this point and I can say x and y. Okay. So or other way around, I can draw this. So L or R theta, like that I can actually define. For example, now if I want to define this point, how many variable required? So I need to have L theta or x y, or even I say this L1 and L2 are known. I say that this is phi 1 and this is phi 2. So you can see like phi 1 and phi 2, right. In the sense what you can actually like see it. So the minimum number of variable to describe the system is 2, right. So that is what the case. So now you can actually like look at the other way around. You take a simple pendulum. Okay. So now I want to know this position. Okay. I give this L. So now you say that this is the P, so x y. So now do you think that there is 2 variable required to define this? No. If I actually like know this angle theta, so I know L is constant, so I can easily find this position, right. So now there may be one question, sir, so L also required, why are you mentioning that? So this is independent variable, this L is constant throughout, right. What is the variable? The variable is actually like theta. In the sense, for defining this particular system, you need actually like one variable, which is theta. So in the sense, what would be the degree of freedom here? It is actually like 1. The same thing in mechanics we can actually try to understand. If you are looking in a motion system, so if you take any free body in space, so how many variable you need to require to or you can say describe the system? It required 3 translation and 3 orientation. In the sense, it required 6. So if you have actually like n number of body, how many degree of freedom would be there, or how many variable required? It would be n into 6 or 6n, right. So now I am actually taking one body and constrained with another body. Okay. This is ground, I am actually like confined this as a pin joint. So now how many degrees are there? So ground 1 and this is another one, there are 2. So in the sense 6 plus 6, 12, but this can actually like move only one body. So in the sense 6 is another 6 is subtracted. Further what happened, this particular pin joint will allow only one rotation. It cannot, it is actually like proper collar, it cannot come out, it cannot go out, it cannot actually like go this way, and it cannot actually like rotate this or rotate independently. It can rotate only vertical axis. In the sense, it is 1D of system. This is what you have seen here, right. So in the sense, so degree of freedom is nothing but minimum number of variable to describe the system. So now I hope you would have already studied your what you call Grubler's criterion and the Chebyshev equations and all. So I am not actually like talking that, but you can recall the degree of mobility or degree of freedom in general can be written as based on the number of body. So I have, it is in 3-dimensional space. So n minus n is the number of body, and this is actually like number of 1D of joints, and this is 5, and this is actually like number of 2 degrees of freedom joint, and this is number of 3 degrees of freedom joint. In real there is no such 4 degree 5 degree joints and all, so we can restrict this. This is 5. Okay, so this is actually like 5 J1 minus 4 J2 minus 3 J3, which is actually like going to give. I hope this equation you would have studied in your, you can say, mechanics, but right now what mechanics says that the degree of freedom of a mechanical system is the number of independent parameters that define its configuration. Configuration means how the body is arranged one to another. That is what you call the degree of freedom. Now in that connection, what we are actually like seeing in the robotics, so robotics is actually like number of independent movement that an object can perform in a given workspace. Usually what? It's a 3D workspace, is called the number of degree of freedom. Okay. So in that sense, now you are clear what is degree of freedom. There is another factor we supposed to know. So before that I will talk the serial manipulator, all joints are actually like actuated. In addition, these all are actually like 1D of freedom joints, so either rotary or translation joint. So even you have actually like spherical joint, that actuation would be independent, whereas the parallel manipulator, some of the joints would be passive. Further, these joints can be having multiple degrees of freedom joints. For example, you have a universal joint, spherical joint, these all can come in the parallel manipulator, whereas the serial manipulator it cannot come directly. Why? Because this is all joints are actuated. So let us move further. We said one additional parameter you should know, what is that called? Degree of manipulability. So what is manipulability? So it is basically nothing but number of controllable inputs or active joints. By the name itself you can see if it is a serial robot, if it is a serial manipulator or serial robot simply, the serial robot would be, so the degree of freedom and degree of freedom and degree of mobility are same, but whereas if it is actually like parallel manipulator, it is not so same. Okay, so that is what I wanted you to actually like understand. So the controllable inputs are different and degree of manipulability is different. For example, even you want to understand, so I am just giving, it is actually like a planar manipulator. Okay, it is a planar manipulator, it is having, you can say, 4 motor. So each motor can rotate, so omega 2, omega 3 and omega 4. So now, so how many variable to describe the system? Since it is in a plane, it required even this orientation all include. So p, x, y, and the orientation I call this is with respect to x axis, this is parallel to x. So this angle called phi. In the sense, these are the 3 which is minimum number of variable to describe the system. But how many controllable input? So omega 1 to omega 4, in the sense 4. Now you can see even though it is a serial, but it is not having this match degree of freedom to degree of maneuverability. But most of the case these are same, but you can see like even one simple instant this is not same. Now you are clear like what is manipulability. So further you can see this manipulability is already I said usually considered as a degrees of freedom, because the as per mechanics most of them are serial, and that too like number of degrees of freedom is actually like less than 6 or equal to 6, in the sense controllable axis would be maximum 6. If you have a redundant robot, so then you cannot call it as 7D of system strictly speaking, but commonly we use the system is 7D of system, 8D of system, but we need to describe in space only 6 variables required, right? But you have 7 input, in the sense it is a redundant, so that we can actually like see further on. We will classify even robot, holonomic robot, redundant robot, and under actuated or under or non holonomic robots and all, but that is not the scope in this particular content. So let us actually like move further. So if the degree of maneuverability increases, in the sense what you are trying to do, you are trying to increase the number of actuator. What you can actually like see, the positional accuracy decreases as per serial robot, because if one robot or one chain, so for example you have error here, this error would actually like accumulate further. So that is why I say if you keep increasing the degree of you can say manipulability, the you can say the positional accuracy decreases. Similarly, the computational complexity and cost increases, because you are increasing the number of controllable inputs, so the complexity is definitely increased and cost also increase because you are increasing number of actuator, in the sense number of additional component. But what you get benefit is actually like the flexibility. So you will get hyper redundant, in the sense you are having a flexible condition. For example, the conventional robot you call the holonomic robot cannot do, but the flexible, in the sense hyper redundant or redundant robot can actually like do it. So for example, I shown right 4D system in the previous slide, that can actually like do much higher. Further, what happens, since you are keep on adding in serial, so what happen, you need to actually like deploy the power connection accordingly, in the sense you have a restriction in the power transmission. So these are the cases. Let us actually like move one slide further. So now you know like what is manipulability. So I just give this slide here. So what would be the workflow of a robotic engineer? So you know all the engineers will give the task to be accomplished. So the other side, what you have, the task, for example, I am saying that the robotic assembly. So then you will see the real system. The real system would be, so what would be the real system? The real system would be the manipulator. So how will you choose the manipulator? On shelf, the manipulator will start from 2 lakhs to probably even 2 crore. So it's very difficult, right? So from the task, what one can get, the desired specification you can get it. So based on the desired specification, what one can find, you can find a tentative configuration. So the selection of configuration you can do, but the real system required at least 3 input. So one would be the selection of actuator, the other would be selection of the mechanical structure, the third one would be selection of you call control, or you can say sensors, because you need to have a closed loop. So now you can see the selection of configuration is come from one end, but selection of actuator, you can say sensor and mechanical system is the other side. So somebody has to fill here. So who would be filling? So we are going to cover in this course is nothing but that we call system dynamics. So simply you call in the robotic, the robot mechanics is going to cover. So in the sense what we are going to see here, the robot mechanics. So that is what we are actually like going to see in this particular course. So now you got clarity what supposed to be required and what we are actually like trying to do. Very simple example I will give and end this course. For example, I want you to make simple pendulum which has a 5 kg as the bob weight, okay, and the length is actually like 1 meter, and this should be motorized, in the sense it is a simple 1R rotary actuator you can see. So whatever angle I am giving, that is supposed to be keep as such with even 5 kg load. So then if I ask you to fabricate, what you will see, so you cannot glue the metal rod with metal bob, right. So definitely you have to see what to be done here. Similarly, this actuator you have to see what would be the minimum torque, and this support you cannot simply glued. You have to see what would be the you can say proper support, so that you can put a bearing and put a proper fasteners and everything. Similarly, this is supposed to be a proper cross section and material required. So in this case, so you need to have a detail about each and everything. So you need to fulfill your motion requirement, you should fulfill your structural requirement, right. So both you required, in that sense you should know one of the important aspect is robot mechanics. When you talk about the robot manipulator, so how they build, how they achieve the motion. So you need motion dynamics and structural dynamics. So that is what we are going to cover in this particular course hereafter. So with that, so I am saying thank you here. We will see next lecture, the robot mechanics introduction. So until then, see you, bye, take care.